Now, in this second video, we will discuss about the transmission of fluid pressure or Pascal's law. Now, this part I am going to move very fast because you have already studied this in your lower classes. The things that you have to understand or remember here, first one is the law of Pascal. First one is the law of Pascal. I suppose you can get the definition or the law of Pascal from the book that you have. The pressure applied at any point of a confined liquid. The pressure applied at any point of a confined liquid. The liquid should be confined. It should be confined. It is transmitted. The pressure is transmitted with undiminished or the same magnitude. Undiminished or same magnitude in all directions throughout the fluid, and acts normally on the surface in contact with the fluid. Normally means perpendicular. I repeat the definition. The pressure applied at any point of a confined fluid is transmitted with undiminished magnitude in all directions throughout the fluid and acts normally on the surface in contact with the fluid. So you can study this part from the book. Now I will move straight forward into the application of Pascal's law, that is principle of multiplication of thrust. Principle of multiplication of thrust. Now, what do we mean by principle of multiplication of thrust? Those who have already studied this thing, you can skip. Let us take a smaller piston and a larger piston. Let this to be two pistons. Fluid in the type of oil or water. Water is not placed here because of some difficulties. So any kind of oil can be put here. Now if we apply pressure here downwards, the piston will move downwards and this piston is going to move upwards. So the thing that is transmitted, or the physical quantity that is transmitted through this liquid is pressure. So the transmitted physical quantity is pressure. So the pressure at these 2 points, this smaller piston and that of the larger piston, must be the same. So if the area of cross section of this piston is A1 and for this is A2, force applied be F1 and F2. So from this we get F1 by A1 is equal to F2 by A2. So the pressure at the two pistons must be the same. Now we have to calculate F2 because F2 is the output. F1 was the input. That means we are applying the force on the first piston. Now F2 is the result or the output that we are receiving from this part. So F1 into A2 by A1. Now already we have studied that F2 by F1, you can write this in this fashion also. F2 by F1 is equal to A2 by A1. Now A2 is greater than A1. From the diagram we can get A2 is greater than A1. That means we can say that F2 is greater than F1. So we have multiplied thrust. The amount of force applied here or the thrust applied here gets multiplied according to the same ratio as the ratio of the two areas. Now a very important question, conservation of energy in case of multiplication of thrust. Now in the first sight you can say that the principle of multiplication of thrust violates the principle of conservation of energy. But though we get a greater force on the larger piston by applying a lesser force on the smaller piston, we cannot gain energy. Now suppose if we can redraw this diagram, we had applied a small force F1, F2 was the force that we had received on the larger piston. Now suppose this piston moves down a distance of x. So this piston will rise above by distance y. Now the area of cross section of the piston, now suppose if you can take it as A and this as B. Now the volume of liquid that has gone down and the volume of liquid that has gone up in the second piston, both the volume of liquids must be the same. So we can write AX is equal to BY. A is area of cross section into length, B was the area of cross section into length of the larger piston. From this we get XY is equal to B by A. Now the work done on the smaller piston. Now if we can write the work done on smaller piston. Now F1 was the force and displacement work means force into displacement. So F1 into X, and the work done on or by, I can say the work done not on, by, because we had applied the force on or force F1 on the smaller piston, and work done by the larger piston, we can write it as F2 into Y. Now what is F2 into Y? We can write, instead of Y or rather instead of, from the previous part we can say that F2 is equal to F1 into B by A into Y. F2 was F2 by F1 is equal to B by A. From the previous principle of multiplication of thrust, F2 is equal to F1 into B by A. Now F1 into, now B by A is equal to X by Y. So replacing B by A as X by Y into Y, so Y gets cancelled, F1X. Now F2Y is equal to F1X. That means the work done on the larger piston, work done on larger piston, that is F2Y, is equal to work done on smaller piston. Or in other words, the energy expended on the smaller piston, can be recovered as the work done by the larger piston. So the principle of conservation of energy is not violated but is valid in this case. Principle of conservation of energy is valid in this case. This is the proof. Now in the examples of the multiplication of thrust, we have taken two pistons, but one thing we have not considered here is the force of friction. Effect of friction is not considered but in actual practice, however, some amount of energy is dissipated as heat in performing work against friction, because when the piston moves up and down, the wall of the cylinder and the piston has frictional force with it. So the frictional force causes energy to be dissipated in the form of heat in performing work. Now work done on the larger piston is less than the work done on the smaller piston. If there is frictional force present, then work done by the larger piston must be less than the work done on the smaller piston, because the amount of work done by us on the smaller piston, that some part of the work is dissipated as heat, some part of the work or energy, you can say, is dissipated as heat, so we do not get the same amount of work on the larger piston. Now this principle is used practically in the hydraulic press. I am hydraulic, I suppose, LIC, hydraulic DRAUC, LIC, hydraulic press, hydraulic brakes, the brakes that you find in cars, and also disc brakes in the motorcycles, hydraulic lifts. Hydraulic lifts you will find in the petrol pumps, that is cars are and buses are being lifted on a rail to clean the bottom part. You can study all these three things from the book. I will not go into greater details in this part of the theory. And this is the diagram for the hydraulic press. We are applying a pressure force F1 on this piston. The pressure is being transmitted and the piston F2 is being pushed upwards. Large chunks of materials are placed here. The pressure applied on this part, these chunks of materials break into pieces. Now, from the principle of multiplication of thrust, we can also increase the fractional part by applying a second class lever here. Now we will be gaining a mechanical advantage by using this kind of or rather a second class lever. We can get a mechanical advantage here also. So we have to apply a very less amount of force to get this chunks to be broken. You can study this from the book. I am going to show you another diagram, that is the diagram of the hydraulic brakes. This is the picture of the hydraulic brake. Now this is the brake pedal. You push the pedal, oil is being filled in these lines. This is one piston, this is another piston. So when we push this, the oil moves into this. The volume of oil in this part increases, pushing those two pistons outwards, which in turn interlocks this part of the wheel and the wheel stops. And this is the diagram for the hydraulic lift. Force applied on the smaller piston can lift a car or a bus so that they can clear off the lower part of the vehicles. Now let us start with buoyancy or buoyant force, you can say. Now what do we mean by buoyancy? You all know it. The ability of a liquid or a gas at rest to exert an upward force on a body immersed in that fluid is called buoyancy. Also, you can say the upward thrust exerted by a liquid or a gas at rest on a body, partly or totally immersed in it, is called buoyant force. That means whenever we try to immerse a body in the liquid, if the body floats, then it becomes a little bit easier to understand what buoyancy is. But if the liquid sinks, it will be a bit difficult to explain what is buoyancy. The reason for this block to float is the buoyant force. Now, whether the body sinks or whether the body floats, buoyant force will always act on the body. Why the body sinks? Because the weight of the body is more than that of the buoyant force. We already know that buoyant force is an upward force or upward thrust acting on the body, and the weight of the body is always acting downwards. So if the weight of the body is much more than the buoyant force, then the body will sink. But if the buoyant force can balance the weight of the body, then only the body will float. This we will study in the part of the flotation part. So the weight is acting downwards, the buoyant force is acting upward. Now, what is buoyancy? We have studied that is the upward thrust exerted by a liquid or a gas at rest on a body. Now, how do we measure this buoyancy? This measure of buoyancy, you can write that what is buoyancy? It can be the weight of liquid displaced, as simple as that. That means this part of the solid has displaced some part of liquid. Now the volume of this part of the solid, let it be V dash. So V dash is the volume submerged into the liquid. So V dash into density of the liquid and not that of the solid, weight of the liquid displaced. So rho L, or rather the density of the liquid is rho L. So rho L is the density of liquid. Rho is the density of liquid. Rho L into G. So V dash rho L into G. This will be the value of the buoyancy, or rather the force or the upward force, you can say upward thrust on body. The cases for which the body can float is that the weight of the body, or rather mg, is greater than v dash rho l g, sorry, less than equal to. If this is less, then it will float. If it is equal to, then it will float, but it will be completely submerged into the liquid in this fashion. It will float, but with this full face into the water. So mg less than equal to, less than means in this case some part of the body will be above the liquid. But for mg equal to v dash rho l g, the body will float, but the surface of the, or the top surface, will lie beneath the liquid, and the body sinks. This is the condition of flotation. And if mg is greater than v rho l g, that means the weight of the body is more than the upthrust, then the body will sink. Very simple. Center of buoyancy, very important thing to understand. The point where the center of gravity of the liquid or gas is located before it is displaced by the immersed body is the center of buoyancy, or the center of flotation of the immersed body. Now the point where the center of gravity of the liquid or gas is located before it is displaced, that means if we take a body floating in the liquid like this, so this is the portion of liquid that is displaced, this is the portion of liquid that is displaced. So in this place, when the body was not immersed, there was liquid. Now the center, what I have stated is the center of gravity of the liquid or gas before it was displaced. So when there was no solid in the liquid, then this portion was occupied by liquid. The center of gravity of this portion, of liquid is known as the center of flotation or the center of buoyancy. Reaction of buoyant force. Now, when a body is immersed in a liquid, the displaced liquid exerts an upward buoyant force on the body, and according to Newton's third law of motion, we can say that the body also exerts an equal and opposite reaction on the liquid. The body also exerts an equal and opposite reaction of the on the liquid. The existence of this reaction can be realized from a very simple experiment. Now we take a beaker containing water placed on a pan of a common balance, and by placing the required counterposing weights on the other pan, the balance beam is made horizontal. Now a piece of iron is tied by a thread so that the piece of iron does not touch the wall of the beaker, and it is immersed into the water. Now, if you can draw the diagram will be a little bit difficult to draw. This is one pan, this is another pan, this is the pointer. Now we place a beaker containing water in one pan. Beaker containing water is placed on one pan of the common balance, and we place weights here. Weights 1 kg, 2 kg, 3 kg, those weights, counterposing weights as we say, on the other pan. Now the beam is balanced, that means the beam is made horizontal. Now a piece of iron tied by thread, tied by thread is immersed into the liquid. Piece of iron tied by a thread is immersed in water by holding the free end of the thread, so that the piece of iron does not touch the wall of the beaker. We must take into consideration that this piece of iron does not touch the walls of the beaker. Now it is seen that the pan with the beaker immediately goes down. Pan with the beaker, this has a tendency to move downwards, or rather it moves down, it goes down. As the liquid exerts an upthrust on the piece of iron, the liquid is exerting an upthrust on the piece of iron. So the piece of iron will in turn applies a downward reaction on the liquid. I repeat, as the liquid exerts an upward or upthrust on the piece of iron, the iron piece at the same time applies a downward reaction on the liquid. This reaction ultimately acts at the pan, hence it goes down. The pan goes down because of the reaction force by iron on beaker, in turn on beam balance. So it goes down. Archimedes principle. You all have studied Archimedes principle in class 9 and 10. Little bit of revision and some new applications from where mathematical problem comes in the examination. Now Archimedes principle, very simply we can state that when a body is totally or partially immersed in a liquid or gas, or that means fluid, at rest, it appears to lose a part of its weight. That means if a body is immersed in a liquid or something, there will be a loss in weight. The body itself, if we humans, when we try to swim, we find our body a little bit lighter. It appears to lose a part of its weight. Now this apparent loss of weight is equal to the weight of the liquid or gas displaced by the body. This was found out by Archimedes. I repeat, the apparent loss of weight, the amount of weight loss is equal to the weight of the liquid displaced, liquid or fluid displaced, liquid or gas displaced by the body. This is Archimedes principle. Now Archimedes principle is related to the weight of the body. So this principle is not applicable for a body in a weightless condition. That means the weight of the body in an artificial satellite or in a freely falling situation is zero. So in these cases, Archimedes principle is not applicable. Remember, Archimedes principle is not applicable because in this cases because it is related to the weight of the body, and we all know what is weight, m into g. So g, that means within the earth's entity. If we move out and the value of g decreases at a point in this, that is in space where there is no g, that means it will be a weightless condition. So the weight of the body in this artificial satellite or in a freely falling situation is zero. Artificial satellite or in a freely falling situation is zero. So the statement goes as Archimedes principle does not hold in freely falling body or artificial satellite, as weight is in these cases is zero. Now application of Archimedes principle. This is a new thing to you. First one is volume of a solid of any shape. This here we will derive mathematical expressions for these three cases. Volume of a solid of any shape, we can determine the volume of a solid of any shape. Second point is we can determine the density of a substance, and we can find out the composition of an alloy. Alloy means a mixture of two metals. We can find out the composition of the alloy. Now the first case, determination of the volume of a solid of any shape. Determination of the volume of a solid of any shape. Now this method which I am going to describe below is the simplest one to find, and the volume of a body of any shape. The first derivation, determination of the volume of a solid of any shape. First case is body heavier than the liquid. We will also discuss a case in which the body is lighter than the liquid. Now if W1 is the W1 is the weight of body in here. Now W2 is equal to the weight of body in, you can write water, or you can write liquid. W2 is the weight of the body when the body is immersed in a liquid. Now according to Archimedes principle, W1 minus W2. Now what is W1 minus W2? This is the apparent loss in the weight of the body. You can write here apparent loss in weight of body equal to the weight of the liquid displaced by the body is equal to the weight of liquid displaced by body. So you can equate W1 minus W2 is equal to V rho G. You can V rho G. Already we had found out the value of the weight is mg. M means volume into density. So it becomes, the weight becomes V into rho into G. So what is the volume V? That is W1 minus W2 by rho G. W1 minus W2 by rho G. Minus W2 by rho G. W1 minus W2 is equal to V rho G. That means the value of V. What is V? It is the volume of the body. Because if the body is heavier than if the body is heavier than the liquid, then obviously the body will try to sink. Hence, the whole part will get immersed in the liquid. So I've written here V is equal to W1 W2 by rho G is equal to volume of the body. Now, body lighter than liquid. W1 is equal to the weight of the body in air. W2 is the weight of sinker in the liquid. Now, as the body is lighter than liquid, so the body will not get immersed into the liquid. So we have to take the help of a sinker. The weight of the sinker in the liquid is W2. Sinker can be of a iron piece. Now W3 is the weight of body plus sinker, weight of body and sinker tied together inside liquid. Now according to Archimedes principle, apparent loss in weight must be equal to W1 minus of W3 minus W2, because W3 minus W2 means this is the weight of the body, because weight body plus sinker was W3 and only sinker was W2. So W3 minus W2 and subtraction of this part from W1 gives the apparent loss in weight, because this is the weight in air, this is the weight in water. W3 minus W2 means the weight of the body in water. Now if the density of the liquid is rho, if density of liquid is rho, so volume of displaced liquid. How to find that out? Very simple, W1 minus W3 minus W2 by rho G, because this was equal to VdG. So the volume of the displaced liquid is equal to W1 minus of bracket W3 minus W2 by rho G is equal to volume of body. Now to calculate the density of a substance, from the first case we have taken the formula of V is equal to W1 minus W2 by rho G. Now what is the density of the material? That is mass by volume. Now what was the mass of the body? 1 by G. W1 by G. Weight was equal to mg. So m is equal to W by G by V. Volume is V. That means W1 rho by W2 minus W1 minus W2. Here we have replaced the value of V in this equation. We get W1 rho is by W1 minus W2. Now from the measured values of density, the purity of a metal can be known. Now if the measured value of the density is equal to the actual density of the metal, then you can say that the metal is pure. Density, if the density of or rather the measured value of the density is equal to the actual density of that metal, then you can say that the metal is absolutely pure. Otherwise it is impure. Alloy composition, that means to determine the composition of alloy. Now suppose we take one metal, one part we name it as A, another part of metal is known as B. So mass of the alloy be W1. So, or rather you can say, okay, rather the weight or the mass of alloy equal to W1. We can write the weight when immersed completely in water or something, that is W2. Now according to Archimedes principle, we get V is equal to W1 minus W2 by rho g. This we had already found out in the first point. W1 minus W2 by rho g. Now the amount of masses and the densities of the metals, so let be Ma for this, Mb for this, mass of A and B, and also rho A, rho B respectively. So volume of metal A, how do we find out? Volume means mass by density. Volume is equal to mass by density. So Ma by rho A. Again, volume of metal B, M by rho B equal to W1 by G minus Ma by rho B. Now why did I write W1 by G minus Ma? This was Mb, means the total weight was W1. So W1 was equal to Ma plus Mb. So the value of Mb must be equal to W1 by G. Ma plus Mb total into G, Mag plus Mbg. So W1 by G minus of Ma gives the value of Mb, W1 by G. Now the equation can be written as Ma by rho A plus W1 by G minus Ma by rho B must be equal to W1 minus W2 by rho G. W1 minus W2 by rho G. Now you have to do the solve in the next page. So the line goes as we take this part onto the right hand side.